Hello, everyone, and welcome to another Grease Thief Thursday. Today, we will be talking about motor operated valves, also known as MOVs. So, today we have a special treat. We will be showing some previously recorded YouTube videos today. So, Rich will be the one in those videos. So, I'll give a little introduction for Rich. If you don't know me, I'm Marissa, and I'm a senior chemist here. But I'll talk about Rich, who will be in the videos. Rich has 25 years of experience in the development of condition-based maintenance programs and the applications of diagnostic technologies for industrial equipment. His past experience includes working at 3 Mile Island, Limerick, and Peach Bottom nuclear power plants. He is responsible for the design and the development of Peach Bottom Oil Analysis Laboratory. He has also designed numerous innovative products to improve the practice of oil sampling analysis. He also designed the sampling tool used for taming grease from MOVs, and he has helped advance the ASTM standard practice for obtaining in-service samples of lubricating grease, also known as D7718. And he's also certified in the International Council of Machinery Lubrication, also known as ICML, and he's certified all the way up into a machine lubrication engineer, also known as MLE. So today we'll be talking about the MOV kits. So I can go ahead and stop sharing my screen. Just give me 1 second. So today we're talking about the MOV kits. So I can show you what an MOV kit has. Here we have our Grease Thief kit, and over here you can see it says MOV. So we know this is our MOV kit. And what's inside an MOV kit? Inside we have our instruction cards that tells you how to take a sample. We also have our sample IDs that have our sample labels that have a barcode, and they also have different information that you can put in for your sample, so those are included in your kit. We also have your tube that will be used for shipping. We also have some yellow caps in there as well. And then the main thing in your MOV kit are going to be your 8 MOV Grease Thieves. These are type 2 Grease Thieves, and what makes these different than regular Grease Thieves is they have what we call a stinger. And I can show you here. So here's what we call our type 1 Grease Thief, just a regular Grease Thief that we normally see. And over here we have our type 2 Grease Thief. This Grease Thief, as you can see, has a stinger probe. And what the stinger probe does is it helps allow the grease to push through until we hit a gear. Once we hit a gear, it pushes the piston back, and we're able to get a good sample. So side by side, you can see the difference between your Grease Thief Type 2, which is used for an MOV or other gearboxes. This is also great to use if you don't know the depth that you're sampling, because again, once it hits your depth, it will go ahead and get a good sample for you. So this is Type 2, and this is your Type 1. Both of these can be used with our T-handle, which we will be discussing today as well in our videos. So here our T-handle is also used to be able to get a sample from a precise location inside the gearbox. So how this works is we can use it for our type 1 Grease Thief, and we can go ahead and put this in. And what this will do, if I zoom in, we have our little thing at the bottom of our T-handle, and we are able to push this then forward. As I'm pushing this forward, we're able to then core the sample and get a good sample. And you're also, as Rich will mention in the videos, we're also able to adjust our different heights of the T-handles. Again, we're also able to do this as well with our Type 2 Grease Thief, which is used for stinger probes, mainly used in MOVs, but we can also use them as well in other gearboxes. And again, it's going to be the same action where we are going to head and we're going to head and push that forward. We're going to core that sample and get a good represent sample of the grease. So without further ado, I will share some awesome videos with you. Our first video is a little bit short, and we will just be showing what a borescope. We took a borescope and we put that into an MOV, and we're going to show you the flow of grease inside an MOV. So I'll go ahead and share that right now with you.
an SMB0 limit torque about half full with MOV long life NLGI, grade 1 or 0. The actual consistency of this used grease is slightly less than the new MOV long life NLGI 1. The actuator is first placed into a closed operation for about 40 seconds. Then the valve is stopped and placed in open operation for about 40 seconds. During this time, flow of grease can be observed. The flow shows the location that will be sampled by the Grease Thief sampler, and the recirculation of the grease, and the appearance of particulate and various colors of the grease indicate the mixing flow in this region that will aid in obtaining representative samples.
Showing the flow of grease. Our second video is going to show demonstration of what we call our stem thief, which is a relubricating tool that we use in our MOV. It also can be used in multiple MOVs, so it's our relubricating tool. We will also see demonstration of how to use a T-handle in an MOV, as I mentioned earlier, and we will also see the difference, which will demonstrate our Grease Thief Type 2 and our Grease Thief Type 1. So I will show you the next video as well, where Rich will explain this as well. This was pre-recorded, so keep in mind this was recorded on a conference, so keep that in mind as you watch this.
Yeah, thanks, Domingo. Can you hear me okay? Wonderful. So I'm going to show a couple things here today. We have a test stand with a SMB0 and an SMB00 here in our laboratory, and we've used this to do some different research projects with EPRI and testing and so forth, and development of some tools for both relubrication of valve stem and stem nut. And we've heard a number of presentations today talking about frequency of tasks. We've heard about assessing the condition of the grease, and we heard about relubrication of the stem and stem nut lubricant. And so I'm going to show this tool, which is called the Stem Thief. Last year's conference, Domingo, Ken Brown, and I did a presentation talking about greases. Part of that was discussing this tool. I figured today with its remote format gives me the opportunity to do live demonstration. And like Domingo said, feel free to ask a question, and I can kind of show or demonstrate while I'm doing this one of the benefits of going live here. So I've got the stem cover here. It's not the right size, but it just kind of demonstrates what we would do is remove the stem cover to access the valve stem, this being an SMB0. And the key components to the stem piece are a threaded adapter. And so this adapter has a pipe thread, which is going to be sized to match the size of the motor operated valve actuator, the thread for the stem protector. And then on the inside bore, there is a straight thread. So I'm going to start by placing that adapter over top of the stem and just making a couple of turns here till it engages into the stem protector threads. And then this is the lubricator tool. So it just has a protection for cleanliness there, a little cover. And when I remove that, you can see that there's a whole board inside. There's an O-ring here. And then you've got this straight thread cut into the outside of the tool. And this straight thread is going to engage with the straight thread in the bore of the adapter that I just placed there. That's going to allow me to thread this down, and as I do that, that O-ring is going to engage the top of the stem nut. And so we're going to make a seal in this way. So just kind of put that over the top of it, slide it down, and now I can engage this straight thread. So it's just a little knurled section here that makes it easier to thread this down and thread it on. And eventually I get it far enough that I can feel the resistance, and that's going to be the O-ring engaging the top of the nut. So this is custom built to the correct dimensions because it does have to be narrow enough to fit inside of the stem nut lock nut. And right now I've got that O-ring threaded down on top of that. So I've created this chamber, which is connecting this zerk fitting. So I've got a grease zerk fitting here on top. It's going to allow grease pressure to build, go down, engage with the top of the nut, and then because of that seal, force that down through the threads. And so at this point, I would just take a grease gun, put the cover of the grease gun on top, and then I'm going to actuate the handle to pump grease down in. And what that's going to do is it's going to push the old grease out. And for the development of this, we did create a clear 3D printed nut, stem nut. And some of you may have seen this in previous MOV user group meetings where I brought that along and demonstrated it. And it actually shows that the grease comes down and it follows the threads, and you can see that on the clear nut, pushing the old grease out, purging it out through the bottom, and then putting a new layer of grease onto the stem, and of course onto the stem nuts as well. So questions about this: is it going to clean the stem nut and the stem? No, it's not going to clean it. It's not going to strip anything that's hardened on there, but it is going to push the old grease out. It's going to push debris out. It's going to generate a new layer of grease in there without having to disassemble the valve, let's say. Now, this is not a complete, in-service running type of application, because when this tool is on for you to create a hydraulic condition, you would not want this valve to actuate. You would not want the stem to get a signal to go up and down while you're on here. So you'd have to basically put the valve in the position that you're going to do this and keep it there with a lockout tag out. But it's not necessary to remove the valve, to remove the actuator or anything like this. We can do it while it's in place, much lower time. Talking to folks who've used this, like Domingo and some of his colleagues at Popularity, they talked last year at the presentation about safety aspects of this. You don't have to rig this up and out of the way to get access to the nut to lubricate. So one side pushing through to the other side is going to allow us to push that old grease out. Now the another thing that was talked about today was about the condition of the grease, looking at the condition of the grease. And in addition to being able to lubricate, put a new layer of grease in here, we also have the option to come down in this area by the yoke and grab a sample. So we can grab a sample of the grease that's been forced out and either just do a visual inspection of that, or there's a whole series of tests that we can perform to look at the condition of the grease, contaminants that may be present, can look for wear particles, wear of the nut, wear of the stem, and the condition of the grease itself. Is it oxidizing? Is it breaking down? Is it separating? Is it drying out? And so on. So it gives us that analysis opportunity, which is, again, one of the things that we're talking about as we get into these frequency extensions, looking at the condition of the grease, evaluating the condition of the grease is going to help us. Some of this can be done, just looking at it, feeling it, and so forth. But sometimes we want a little bit more. So there is an ASTM standard that governs this. By the way, the testing of greases for MOVs was addressed a number of years ago in not so much an MOV EPRI project, but a lubrication specific one called effective grease practices. And there's an effective grease practices guideline that Nick Camilli and I worked on that talks about sampling and analysis of greases. So when this is done, you can then just back this off and bring that up. And if you don't get too crazy putting the adapter on, it should almost come off by itself. But just in case it were to get stuck, if it were actually to be, if this adapter nut were to be put in place into the taper of the threads, we do include a spanner wrench. You put the spanner wrench on there and you can get that off as well. So some of the designs of this have come about through folks who've used the tool, given us some feedback on its use, so on. Now I talked about taking a sample of the grease. I want to show a couple options for sampling grease in the gearbox as well. But first I'll address the sample that I mentioned that you could take from down here in the yoke area. And this is one of the kits that would come with the Stem Thief. It has a number of different tools in it. It's all protected, so it stays clean until the time you take the sample. It has this plastic spatula. And you can get down in here and you could gather up the grease. You could gather up the grease from the underside yoke area. You can see this is a no valve, but you'd be able to take that out, and you can put that back up there. And then the tools inside here allow you to transfer that over, take that grease that you have and kind of put it into this syringe, and then the syringe can be transferred into this container, which is the grease thief. So the analysis I talked about takes around 1 gram of grease. There's actually 10 different tests that can be performed with that 1 gram, and this is all under an ASTM standard for grease sampling and grease analysis. So that's one way to take a sample, and that's going to come about while you're relubricating the stem nut with this tool. But what about the gearbox itself, looking at the condition of that grease? Well, here's a possible access point using this plug in the pinion and worm gear engagement area. And there's really 2 ways to do this. One is using this T-handle tool, which has one of these grease thieves loaded into the end of it. And so you can see that I can actuate that. You move that back and forth, and you see the red piston here staying the same in the same position. And then there's an adjustment that can be made here by how far down do I want to take that sample. So once I know where that is, I can set that depth. I can put that in through my opening and then core the sample. And this is an important thing about sampling greases, is that you really do need to be cored. Suction doesn't work very well on greases. So instead of trying to pull it out like a syringe, we're actually putting it down in place with the piston at the end like this until you get to the position you want to sample, and then the body moves forward and cores the sample. So that's one possibility where you know exactly how far in what you want to go. If you're not certain, you can use the same tool with a different device. This is also a grease thief, but this one has a stinger prick on the end of it. So when I move that into an opening, it moves until it touches that surface, and then it takes that sample from that last little bit. So for something like this, for this kind of opening, I can kind of run this down in here. I can move around kind of the supports that are in there and get right alongside the gear, and then advance that to take that sample, pull that out, put a cap on it, wipe it off, take the sample. And, you know, what you find is that the grease that we're interested in testing is not whatever comes out when we just like stick a screwdriver in there or a cable tie or something. It's the grease that's from the engagement area of these gears. So a lot of the other grease sits in place, just kind of waiting for its turn, if you will. We want to sample that grease that's right there in the gear engagement area. And this allows us to target that location within the gearbox, pull that exact grease back out, and perform our assessment on that. And that assessment can be as simple as looking at what's inside the clear body on this sampler. It could be, we're in the field, we want to extrude it out. We can put it on a nice white piece of paper, extrude that out, look for any kind of discoloration, particulate, darkening of the grease relative to, you know, what the new color to be. Or we can cap it up, send it to a laboratory and get more advanced analysis, including wear particles, looking at the condition. You know, and some of the things that I heard today about grease condition, about wear, about life extension, a lot of things we can assess as we get into the later stages of the life of some of these things by looking at how much wear is there and how severe is that wear, and do that on a case-by-case basis with these gearboxes developed. So I'm going to open it up now to any questions that you might have from this demonstration, either from the STEM piece or from the demonstration of the sampling devices for the gearbox. I'm sorry, who was that? Okay. All right. So I'll show this. This is another one of the STEM thieves that was made. This was a triple aught. You can see obviously smaller diameter. It's going to be made with the smaller housing that we have at triple aught. The length of this is really going to depend on the maximum height of a stem position that you would want to lubricate. So if you've got the flexibility to kind of, you know, close the valve, lower the stem, what have you, you wouldn't need this to be as long per se. But the longer it is, the more, you know, the greater the position, let's say, of the stem in height, you can still get in there and lubricate that. And the first time through, you're going to have to fill up this space with grease, but then after that, it's going to kind of stay in there, and that's why we have the, you know, the foreign material exclusion cover on there, and we can then, you know, go from location to location. So generally, the folks who are doing this are buying a couple of different designs for the ones that they want to use for the MOVs, and then being able to use them on multiple machines. So it becomes something you can leverage well and pretty cost effective when you can, you know, use this on 10, 20, 30 different valves, depending on what you have to look at. Thanks for the opportunity, guys. Thanks for the opportunity, guys.
Great. So that was our second video. And our third and final video is also going to be a short one, but it's going to be super great. It's very in-depth, as Rich was mentioning in the previous video about the STEM thief. Here we're going to see an in-depth look at the STEM thief and how it works. A little warning for this video. The audio does go up and down, so be warned that the music gets loud and then it gets soft. So a little bit audio warning. But if you have any questions at all, feel free to put them in the chat while this video is running, and I will continue on to our third and final video.
Hi, we're here demonstrating the stem thief, a method to re-lubricate the stem and stem nut with MOV. Okay, so the first step we're going to take is to put this adapter nut in place. This is going to be a pipe thread that will engage into the housing of the MOV. In this case, we're just using this thread on our test stand to get us started. And then we'll take the lubricator, which consists of a straight thread on the outside, an O-ring to create a seal between the stem nut and this lubricator, and then a Zerk fitting at the top to introduce the new grease. So slide that over, thread that down. Now in this window, you should be able to see this lubricator come down and engage the top of the nut. Area of the stem nut, and with the clear appearance, we should be able to see the grease come down and re-lubricate those threads. Now, working into the counterboard section of the nut, which is going to eventually fill and then be accessible at the bottom of the nut. So we can kind of take the broad end of the spatula and move away that first grease that emerges, and then go after the grease that's up behind it, which would have been protected and more indicative of the grease that was just there lubricating the stem threads. We take the grease we've captured, place the plunger back inside, take our cap off, pull the plunger back a little bit to put the piston in the middle, and then inject the grease in. You'll see it'll push that plunger back until a little comes out the holes. Then we'll start to withdraw the syringe, push a little bit more in there so we get that filled up. Now we have a full sample. Put the cap over loosely, advance the piston a little bit. The reason for this is there's air in the cap, and if we just push it on, we're just going to squeeze most of the grease out. We move it forward till we'll feel a slight resistance, then we push the cap all the way on. The sample goes into a protective container. Cap goes on. We label it with the motor operated valve number, the plant, other identifying information, send it to the lab for analysis.
I will now open up to any questions. Feel free to go ahead and put questions in the chat. In the meantime, I will put the link to all the videos in the chat as well in case you really want to rewatch them or want to share them. I will put that link in the chat, so go ahead and share that with friends or whoever, and I will open up to any questions at all. So feel free to post any questions in the chat. While people are posting questions in the chat, I will tell you that our next Grease Thief Thursday is going to be next week. So next week we are talking about ATP, which stands for adenosine triphosphate, and that's just looking at detecting microbiology contamination in lubricants. So we will also have a guest speaker as well too. His name's Fred Passman, and he is the leader in biological contamination in lubricants. So he'll be able to join us, which is a really special treat for that next week. So I don't see any questions in the chat. Rich did post the link to stream, to the streaming, which also shows all the videos as well. So if you're interested into the link for streaming, Rich did post that in the chat. Since I don't see any questions, I'm gonna go ahead and close this Grease Thief Thursday out. Thank you guys so much for joining us today. We really appreciate it. I hope you enjoyed the videos. If you have any questions, feel free to email Rich or myself. And we'll be happy to answer those. Other than that, I hope you have a great Thursday, and we will see you next week for ATP. Thanks, guys. Have a great day.